Next problem is related to the chapter 28 and problem number 9. Uh, Equivalent resistance. Three resistance are connected. 100 ohm resistance are connected as shown in figure. The maximum power that can be safely delivered to any resistance is 25 watt. What is the maximum potential difference can be applied to terminal for A, B, this A and B. For the voltage determine part A, that is voltage find it. What is the power delivered to each resistance? What is the total power delivered? So that is the question. So since this there will be a current I. Okay, so what is the this current I will be passed through this, and the same current I will be passed these two resistance that will be divided into uh, I divided IA and IB. Okay, since this current I will pass through this 100 resistance, and this same current will be passed through all the resistance. So at AI and B, so as we know that uh, P is equal to I square R, and the R will be the same I will be passed through this 100 ohm resistance and these R resistance. So maximum power uh, mean the the I max, and this R mean the this I will be same for R1 as well as to these R resistance. So we may say that we may take the I cross the 100 ohm, and this is constant as we know that is 100 ohm. Why we are considering? Because I is crossing this and these all the circuits. So the same I will be passed through this ohm resistance and the combination of these. So so maximum power may be calculated from here. That will be equal to uh, maximum power is given. So, okay, sorry, maximum power is given, that is 25 watt, and maximum I square is I have to measure that is 100. So this implies that I will be what will be I? That will be 25 over 100, and that will become 0. 1 minute, 0.5 ampere. Okay, that is the current. Okay, that will be a current. Uh, Current. Now we have to find the maximum. What will be the equivalent resistance? Firstly, we have to find the voltage drop across this. We have to find voltage required at A and B, maximum voltage. We have to measure the resistance, total resistance. What will be the total resistance? As we know that total resistance, that is R. That will be R. That will be equal to R 100 R1 plus parallel resistance 1 over 100 plus 1 over 100 minus 1. So that will become 150. Okay, that by calculator we can measure, that is 150 ohm. So what will be the maximum voltage that delta V max? Yes, that will be equal to this total resistance and maximum current. This is, sorry, this is a maximum current. Okay, so this maximum current, uh, and from here we will measure R. What is the R? 150, and maximum current is 0 0.5. So uh, that will become 75. Okay, that will become 75 volt. So that will be a maximum volt. Okay. So next, what is the our next? What is the what is we find? I have find now we have to find the voltage. That is 75. That is A and B. Now we have to find the total. Now we have to find the power delivered to each resistance. What is the total? Firstly, we will easily find the total power delivered. That will be a P. P total. Yes, that will be equal to total current, maximum current, total current I, that is I, maximum current, and total delta V, that is delta V, that total current, and this. Okay, so total current will be I max and V max. So that will be maximum current was 0.5 and maximum voltage is 75. Okay, so the result will be equal to 37. That will be a maximum power. Okay, watt. That may be a that may be measured in the watt. So this will be a maximum total power. Okay, now we have to find the power delivered to this and this resistance. Okay, we have to find I square R. Okay, and we know that power have to find the power delivered at this and this. Okay, so for PA, as we know that this maximum current, as we know that this maximum this maximum current is divided into IA and IB. Because the resistance is the same, the current will be a same and divided in two parts. So this will be I max plus I max half half. Okay. So we may say that IA equal to IB. That will be I max over half, and PA will be equal to IA square R R, the resistance RA, and IA square and that will be IA is one half of the maximum current, that is Yes, maximum current is 0.5. Okay, 0.5, 0.5 over 2. So that will be equal to 0.25. Okay, 0.25. So 0.25 square over RA is 100, and that will be equal to, as this will be a 0 point, that will become, when we calculate it with the calculator, this will be a 6.25 watt, and that will be for the same for power delivered at B, because uh, this IA and IB is same. So that is also, so this P2 is so these will be the same. So PA as well as PP, that will be equal to 6.25 watt. That is our result. Uh, this will be a total power. This will be a total power deliver account the total resistance. This A from A and B. So one question, what is the power delivered to such? Okay, what will be the power delivered to this resistance R? That will be also, and power delivered to P1, that will be I1 square R 1. I1 is I max square over R is 100, R1. So what was the maximum? Maximum was 0.5. So 0.5 square uh, multiply by 100. So so this will give you the 0.25, because 0.25 by 100, this will be a 25 watt P1. So this will be power delivered. So so this will be P1, that will be power delivered to it here. This will be AB will be 6.25 here, uh, and 37 will be power delivered to uh, complete circuit, maximum power delivered to. So this is our result.